right. I kind of do want to start the announcements, but I do better once everything is set up. Hope everyone is doing well, ready for another glorious weekend, or doing what you need to do. Let's see, we're gonna hit done. Let me get these guys. Let's see. And let me start by just a moment. I forgot I need to log into this. Close all these tabs. Pearson, allow. Sign in, come. Allow. And this is the 9 a.m., which is here. This. And allow. We're going to work on week 3 functions. Okay. All right. This is fun. All right. So let me go ahead and share my screen. Start the broadcast. Hey, Mr. Wilson. Okay. Look at this student. All right. All right, gentlemen, welcome. So let's see. So just as far as announcements go, we are at the end of week 3, right? So can anybody guess what the big thing is for next week? All right. Hint, hint. All right. So next week, exam 1 is available, right? So exam 1 is going to be based on the content for weeks 1, 2, and 3, right? So this is what? College Algebra 1 with online lab. So that means sections 1, 1, 1, 2, and 1, 3. Let me see, as far as some heads up about the exam, you get unlimited attempts. The system is set to take your highest score. You have a little over 7 days where you can get maximum points, right? Maximum effort, whatever. But it should become available this upcoming Sunday at 11:11 a.m. and it's due the following Sunday at 11:59 p.m., right? So that's Sunday night going into Monday morning, pretty much at midnight. Again, it's unlimited attempts. The system is set to take your highest score. Also, each time you take the exam, it's gonna permutate or change, right? And so it'll be the same content, but a completely different set of questions. Not the questions are moved around. I mean, like it'll be a completely different set of questions. Also, as a courtesy warning or whatever, I want to say that in order to access the exam, you have to pass the quizzes for weeks 1, 2, and 3. Like you got to get a 70% on those in order to access the exam, prerequisites, whatever, right? So you don't want to sit down to go take the exam and then you haven't completed the prerequisites, and then yeah, right. So you want to make sure that you have done those prerequisites, so that way you can have the most amount of time to try to get as high as possible. You can, and again, with all assignments, you can work on it past the due date. So even though it's due the following Sunday at 11:59 p.m., you can work on it past that and earn up to 90%, right? Because you'll get 90% of all the questions submitted past the due dates. So for this week, for today, we wanted to go ahead and continue section 1.3. Now, again, this is online remote asynchronous. If you are in the Zoom call right now, that means you got your attendance credit for the day, right? So congratulations. You're not obligated to stay. And so again, I just intended to fill the air with, I was just going to go through as many homework questions as I can, but we don't have to talk about this stuff. If anybody has questions from 1.1, 1.2, or 1.3, anything pertaining to exam 1, we can talk about it. I'm just, like I said, I'm just going through the homework to just fill the air. As usual, if you have questions, feel free to unmute yourself or type in the chat. I do check the chat periodically, and I'll check the chat again in about 9 minutes to get the stragglers, right? To get the stragglers. Okay, as far as people like arriving late, okay? So let me check real quick. I think the chat looks clear. I'll go. I think he was here. I know I got him already. Let's see, A, B, C, D, E, F, G. And then, all right, that's fine. Okay. Yeah, and just as also as a reminder, let me see. So this is College Algebra 1 with online lab. So again, for me, the things that I expect of you, like every time we meet, which is basically Mondays and Wednesdays at 9, I just need you to at least log in. You're not obligated to stay. This is online remote, so just, even if you're traveling, just try to make a point to just log in. That's the simple thing. You already have a lot of like leeway with it being online remote. I don't think, asking you to log in and get your attendance credit is too much to ask. I just need you to check in so that I know that you're okay. Also, the other point is be sure that you've been working on your lab, right? So for the other portion that's like counts as 10% of your overall grade is the online Alex lab. To access that, you go to our main landing page on Blackboard, on the left-hand panel, on that burgundy panel on the left-hand side, you're going to see a link, which is like the third from the top, that says Online Alex Lab. You click on that link to access the contact information. My colleague, Dr. Lamar, is facilitating the lab. So just, contact her, and whatever she says you need to do, that's what I expect you to do. And then I want to say at the midterm and at the final should give me a grade for you, and I'm just going to scale it. I'm going to factor it in to scale it to account for 10% of your overall grade, okay? Again, as usual, feel free to either unmute yourself or type in the chat if you have questions, comments, or concerns. And if there aren't questions, I'm just going to try to tackle as many of these homework questions as I can, right? All right, so this is from section 1.3. And again, the question ID you can kind of see right here, right? You should be able to see my screen where it says, this comes from section 1.3, and this is question number 1 from the back of that section, right? So a lot of these questions have the course ID, and it says determine whether the relation is a function, right? So 1.3 is on functions. So a function is just going to be basically where you start with the set of inputs, which is your domain or your x variables, and then you're going to pass them through your equation, and the equation is going to generate a set of outputs. In order for this to be a function, every x needs to correspond to exactly one y. You don't have an x that corresponds to two different y's. If we were plotting those points or looking at the graph, one x having two y's, the 2 points will be stacked on top of each other. And that's an example of something that will fail the vertical line test, right? So the way we have it displayed right now is called the correspondence diagram. And an example of a correspondence diagram failing is what I call a split, where you have something on the left that maps two different things on the right. What we see right now in this form, where we have two different x's going to the same y, I personally call that a merge. Merges are okay, right? For it to be a function. So is this a function? We're going to say yes, final check, and go on to the next one. Now, again, you just have to stop me if I'm talking too fast or if anything is not clear. And then the domain is going to be the set of inputs, right? Let me go to my settings, turn this off. Thank you. The domain is our set of inputs. So that would just be 12, 13, and 2. 12, 13, 2. Hit enter. Excellent. Okay. And then the range is our set of outputs. In this case, it's just 15 and 7. 15, 7. Enter. Look at God, right? Okay. Let's go on to the next one. Hopefully we're all aboard, and we're not all bored. I have definitely noticed that like doing this kind of stuff is easier at this hour than after lunch. After lunch, like my energy is so low, the students' energy is low, like everybody's like, please. And it's always been my experience like that. Even like anytime I was in a math class, like, geez, like anytime I try to do it later in the day, it was just so tough to focus. I personally am the best when I first wake up. Like whatever it is I need to do, when I first wake up, that's the best time for me to do it. This comes from section 1.3, question 5. Determine the domain and range of the relation and then state whether it's a function, right? What's the domain? Again, the domain is a set of inputs with no repeats. So it's going to be, let me see, -3, -2, -1, 0, 1, Is there a 2? No 2. And then 3, right? -3, -2, -1, 0, 1, 3. I'm going to hit enter. All right, let's go on to the next one. Then the range is going to be our set of outputs, okay? So it looks like we got -3, 2, 4, not another -3. We can do -1, and we already did 2, all right? And we're missing a comma. Is it going to let me do it? It usually does not. I knew it was going to do that. Eesh. Come on. Oh, undo. Oh, this is a pain. Let me try this. So if I go like this. All right. Got to start over. All right. So then 3, 2. I was missing a comment. I don't know. My keyboard is like really trippy. Like when I go to do a left or right on the directional pad, it treats it like a tab, and I haven't figured out how to turn that off. So instead of just scrolling left or right, it jumps around to different boxes, and I'm like, man, that's irritating. Okay, I think this is good. This is good. All right. Okay, so is a given relation a function? In other words, if we have repeating x's, then it's not a function, right? Do we have any repeating x's? I think that's a no. So is it a function? We're going to say yes, right? No repeating x's, so we're functional, right? Okay, check. Determine whether the following equation define y as a function of x, right? So for this one, what we would do is solve for y, get y in terms of x, and we just, you can kind of look at the graph, really. You can graph this, right? So if you have, for instance, if we're going to have y equals -x plus 50, you can choose several values of x, find the corresponding y, and it's basically, the graph is going to pass the vertical line test. So every x is going to correspond to exactly one y. So then is it a function? We're going to say yes. Okay. Now this one, if we solve for y, we got to take the square root on both sides, right? So if we take the square root on both sides, can anybody tell me whenever we take square root, what symbol do we have to include?
Plus minus.
Plus or minus, right? And so because of that plus or minus, it causes, we can find where each x basically corresponds to more than one y, right? So because we could find one x that corresponds to more than one y, that means that y does not, this equation does not define y as a function of x. So we're going to say no there, right? Hopefully that was okay. I didn't write it out, but I could if I need to, right? So square root function, right? In general, the square root function, if you were to look at the graph, it's going to be the top half of a sideways parabola, whether it starts at the origin and it just goes off to the right, right? So if you take a parabola, the U-shaped curve, you basically rotate it onto the right-hand side where it opens up going to the right, cut it in half horizontally. And so again, square root is the top half of a sideways parabola. I will learn once we start talking about transformations that plus 24 on the inside is going to move it to the left 24 units, right? We're going to talk about that later on in the semester. So if we have the top half of a sideways parabola that's been moved to the left, right? So then you should be able to see that no matter where you draw a vertical line, it's only going to touch the graph once. Every x corresponds to exactly one y. You can't find an x that's going to correspond to more than one y. So does this equation define y as a function of x? We're going to say yes, because every x corresponds to exactly one y. Okay. Any guesses on this one? If we were to solve for y, either can someone just jump straight to the answer, or kind of get us started on this, on how we start this one to solve for y. All right. Either can you tell me what the answer is and why, or can you just get us started?
Professor Phifer?
Yes.
Would you subtract x squared to both sides?
That's a good start, right? So we're going to have y squared equals 16 minus x squared. And if we're trying to solve for y, how do we get rid of that squared? What's the inverse operation of squared?
You have to find root.
Square root. So then if we're doing square root, what happens?
You have y is equal to plus or minus the square root of.
Right. The rest of that stuff, right? I think that, again, the crux is because of the plus or minus, you could find an x that's going to correspond to more than one y. So then does this define y as a function of x? What's the final result? Yay or nay?
No.
No, right? If I need to write that out, let me know. All right. I feel like that dialogue should suffice. Let me check here. Let me get the student and we'll check the chat in just a moment. He is here. And then let me see the chat.
Professor Phifer?
The last part of question 9. Yes.
When you get a chance, do you mind writing that out?
Yeah, we can write it out. Let's do it. So even though we got credit, we're gonna do a similar one. We're gonna do a similar question. Okay. Let me see. Can I zoom in some? Zoom in a little bit more. How do I feel about that? Let's see. This is good. And I really just want this. Right? Okay. I know I keep saying this. I do intend to. There's a couple of things, couple of more items. Hold on, because this thing is tripping. There's a couple of more items that I would like to do. One is that I want to make a copy of the student notes available in advance, which I just haven't posted it yet. And also, as we meet, I want to make a copy of the instructor notes available, right? So with the student notes, I do encourage you to attempt them in advance once they're available, at least on a day-to-day basis. It basically fills in all the missing components, right? And I just need to set it up. It's not a lot. I just need to do it. I was meant to do it this morning, and I'm not gonna lie, I was totally gaming and I got distracted, so I didn't do it. But I'll get it in there. And basically, what's going to happen is all the stuff that you see me writing, you will get a copy of it, right? And pretty much every time we meet. Okay, so determine whether this defines y as a function of x, all right? So let's start with a copy of the original, which is this guy. We have this x squared plus y squared equals 4, right? So then what we're doing here, we want to solve for y, right? So we're going to use the inverse operation to get the y by itself. So first we move the x squared. Because this is a positive x squared, the inverse operation to move to the other side is subtraction. So we subtracted x squared on the left and right side of the equal sign. Okay. So then a number plus its opposite adds to 0, right? So that's essentially gone. The y squared, the equal sign comes down. The y squared just comes down. These are unlike terms, so we just put them side by side. Okay. So then next, get rid of this. So we're still solving for y, right? So since we have y squared, the inverse operation of y squared is square root. So we take the square root on both sides. And I think we said last time, whenever we take square root, we have to introduce the symbol plus or minus. Okay, this cancels this. And now on the equal sign just drops down. On the left, we have y. And on the right, we have this plus or minus, right? Like this, right? So what it's saying is you can find one x value that's going to correspond to more than one y value. For instance, notice when x is 0, right? So this is just a side or whatever. Notice that when x is 0, right? So then our y is going to be, and this is just like a check, plus or minus the square root of 4 minus 0. Let me make that 0 look a little bit better. Right? So then y is going to equal plus or minus basically what, 2. So when x is 0, the corresponding y is positive 2 and negative 2. So that means that we successfully found at least one x that corresponds to more than one y. So for that reason, this is not a function. Not a function. In order for it to be a function, each x has to correspond to exactly one y. In other words, if you look at the graph, it needs to pass the vertical line test. Hopefully that was okay. Right. Let's hop back here. Let's zoom out some, actually. I know there was a request for number 9. Give me just a second. Okay. I think I'm actually going to jump ahead because I know there was a request for number 9. So save best score. And this one asks to find the domain of this function, right? Okay. So again, Dobson, he's definitely here. So for our discussion, there are really, well, there's actually a third, but there are 2 main topics where the domain comes into play. The first is called rational functions, which is this one, basically the functions where it's like, it looks like a fraction, right? You have one polynomial over another. And in general, for rational functions, the domain is all reals except any x that makes the denominator 0, right? Because we cannot divide by 0. The other case is like basically square root functions or even root functions. We cannot take the square root of negative numbers, i.e. we cannot take the even root of negative numbers, right? So the domain there is x has to be greater than or equal to 0 in general, right? So for this one, with it being a rational function, we can't divide by 0. Can somebody tell me what value of x makes the denominator 0? Or can you get us started on how do we figure that out?
-3.
How did you get -3?
Because when you add 3, the -3 becomes 0.
Right,
Therefore,
right.
you have a 0 in the denominator.
Right, exactly. That's essentially it, right? Another way of articulating that is basically you can set the denominator equal to 0 and then solve that equation, right? If you say x plus 3 equals 0, subtract 3 on both sides, then it shows you that when x is -3, like we were saying, -3 plus 3 is going to give you 0, right? So for this one, all reals are going to work except x equals -3. So we have to throw out the -3. So then which one of these expressions is the only one that excludes -3? Well, not the only one, but that captures that sentence, right? Again, all numbers are going to work except -3. So which one of these captures all numbers except -3? So
B.
let's put a pin in that. Can somebody tell me what's the difference between C and D? What's the difference between C and D? What's the difference? Or even if you don't know what the symbols mean, what pictorially can you see the difference between C and D? Just any kind of
parentheses? Doesn't parentheses mean that it's included, and then the brackets mean it's not?
You got it reversed, right? Reverse that around.
Okay,
So
bad.
this means we get really, really close to that number, but we do not include it. Brackets mean we get really, really close to that number and we do include it, right? So taking into consideration that parentheses mean we do not include that number and brackets mean we do include that number, which one of these captures all numbers on the number line except -3?
C.
C, right? Because A is only talking about the numbers on the right-hand side of -3. B is only talking about the numbers on the left-hand side of -3. We not only want the numbers on the left, but we also want the numbers on the right. And the reason it's not D is because D includes -3, and that's the very one that we were trying to throw out. So C is our candidate. All right, so we're gonna hit enter. Okay, hopefully that was okay. All right, what's the time? Man, these classes go so fast. I'd be so sad. Okay. Anybody feel confident that they can, anybody want to attempt this one? Any thoughts? Okay. Let's take some notes on this one. It's not as bad as it may look. I'll check that later. Let me see. Okay, so find the domain, right? Again, for rational functions, the domain is all reals except any x that makes the denominator 0. So if we're trying to find what x makes the denominator 0, just like in the last example, let's set the denominator equal to 0 and solve. So if we set this denominator, if I need to write it out, I will. It just has to be requested. But if we set the denominator equal to 0 and solve, you add the 1 on both sides, you take the square root. Square root of 1 is going to be plus or minus 1, right? So we have 2 different x values. We got when x is 1, when x is -1, right? Both of these are going to make a 0 in the denominator. So that means we got to throw out those two numbers, plus or minus 1. So then it says the domain is, type your answer in interval notation. So we want to capture all numbers except plus or minus 1. So we kind of do it the same way as the previous, right? The far left, like if you're on the number line, what's the far left? Negative what?
Negative infinity.
Negative infinity. Now, what's the first one that we come to as we move to the right? Is it negative 1 or 1?
Negative 1.
Right. So we do need to do these in order. What did I just hit? Plus. Nope. Nope.
Professor Phifer,
Yes.
I'm kind of confused as to how you got to. At what
Plus-
point did you add the plus or minus?
Okay. Let me write it out. As soon as I can get this in the head. Okay. So let's write this out. Let me see. Get rid of this. Let's go. Oh. So find the domain. All right. Let's next one. All right. So this comes from section 1.3, question 25. There's that and this. Okay. Let's just hop here. Oh, it did not work properly. That's okay. Get rid of that. This one. This one. Cool. All right. So let's write this out, right? So again, for something like this, the domain is going to be all reals except any x that makes the denominator 0. So what we want to do is, I'll do this in this color. We want to set the denominator set our denominator. We want to set it equal to 0 and solve. Okay. So in this context, that's going to be x squared minus 1. We're going to set it equal to 0. Okay. So first we say our plus 1 on both sides, all right? We're using our inverse operation. The inverse of subtraction is addition, and we did it on basically the left and right hand side of the equal sign. Now, I've had students in the past that'll draw a bar for the equal sign, just so that they know they're working on the left versus the right, right? So we're always going from the left to the right, right? You got to say balanced. So they'll draw a bar just to be clear, right? And then, so the equal sign, it always just drops down. We can do like this. It drops down. So on the right-hand side, we're going to have 1. A number plus its opposite. These add to 0. The x squared just comes down, right? And then to get rid of the square root on both sides like before. But whenever we introduce square root, we have to do that plus or minus. Or whenever we do an even root, we have to do plus or minus. So then square root of 1, plus or minus 1, right? So what this is saying is that when x is either 1 or negative 1, it makes a 0 in the denominator. So we got to throw these two out, right? So now if we consider the number line, like the x-axis, where the positive x goes in this direction to the right, we're going to go ahead and plot here's our negative 1, here's our 1, right? Again, we want to throw these two out. So we want to, in interval notation, we want to capture all of these points except for the two red x's, all right? What's the far left called? Like when we go to the far left?
Negative infinity.
All right, so the far left over here is negative infinity. What's the far right?
Infinity.
Positive infinity, right? And so this gives us this image that you see on the right-hand side, that pretty much is what we're using to create the interval notation. So then to go to translate, when we write it in interval notation, the far left is negative infinity. Infinity always gets what kind of grouping symbol?
A parenthesis.
Parentheses, right? What does parentheses mean again?
You're getting close, but you're not including it.
Yeah, but you never reach it, right? In the context of infinity, it basically just means you never reach it. And then we're going the far left is negative infinity up to, now as we trace going to the right, the first checkpoint is -1, right? So we go up to -1. What kind of grouping symbol, if we do not want to include -1, what kind of grouping symbol is it?
A parenthesis.
So in this context, what the parenthesis means, we get really, really close to -1. Let's do it here. We get really, really close to -1, really close. Like if you were to zoom in like Ant-Man, you can find an infinite number of points. I mean, like if you keep zooming, you'll keep finding like a crap ton of points in there. But we actually never reach -1. We don't want to include that point itself. And then the parentheses, we don't include that endpoint. Let me kind of do like this. Kind of running out of space. I should have gave myself a little bit more space. Let me move this around real quick. So I just want to give myself some space. Come on. There it is. I think I'm gonna just move it all the way down here. Come on. And then what I would like to do is like this. Just want this to be a little bit bigger. I'm trying not to reboot my device, but this is fine. I think that's big enough. Okay. So that captures that one. And then now, again, the parentheses stopped us from capturing the -1, which is what we wanted. Now we want to include all the points here between -1 and 1. So we're going to capture that by saying -1, 1. Again, what kind of grouping symbol do these guys get?
Parentheses.
Okay, it's the same reasoning. And then to capture that right-hand side, we're going from 1 to infinity. Infinity always gets a parentheses. In this context, because we don't want to include 1, we put a parentheses. And then the final answer is we're saying that any number from this set or this set or this set will work in the original. So to capture all those together, that's why we use this union. We use this union, right? And so that's what the final result is going to look like there. These are good questions. Like, this is why it's important for you guys to work on this stuff, because if you don't ask, I don't know where you're struggling, or I don't know where you guys are. So I'm constantly trying to get feedback from you guys. That was really good. I really enjoyed that. Okay, so now let's translate. Let me see. Come on. I know you're gonna do that thing I don't want you to do. Yes. Okay. So we said the far left, negative infinity up to -1, and then I'm gonna put cup, right? So to create that symbol, I'm using, this is like some coding language. It's I guess it's backslash. Let me see. Give me a second. Forward, I saw it. Yeah. So this is backslash, right? So to create that symbol, I should have finished. Oh no, it's on that thing. Okay. So what I'm typing is backslash cup to create that symbol. Then I'm doing another parentheses. We went from -1 to 1, and then cup again, which is, it's really called union. Then we're going from 1 to infinity. Oh, and then the symbol for infinity is backslash INF. It'll create that, right? In this platform. So you can actually just type it. Okay, so you guys are mini programmers now, a little bit. All right. Okay, so let's hit enter. God is good. Let me see, we got a solid 10 minutes. Now I can either just choose some questions at random, keep progressing. If you have specific ones you want to talk about, I think that's even better to try to maximize our time, but we got a solid 10 minutes. I want to say feel free. Well, typically what I do with the other students is about the same, but I was gonna say if you wanted to attend other sessions, you can, but it's gonna be kind of doing the same stuff. Let's go to question number 7. All right, this one, right? So determine whether the following equation represents y as a function of x. Now say you're at home, you're working on this alone, and you're just stuck, right? A great place to start if you need support is the view an example. You would just click on that, and it'll give you an explanation behind the reasoning. If the explanation doesn't make sense, then that's a great time to either ask a classmate or a tutor. And then if that still doesn't work, then at that point is the best time to make use of the Ask My Instructor tool. Ask My Instructor basically is going to send me a screenshot of your very question. I'm going to take it, load it to my device like you see now. and make a video response, load the video to YouTube, send you the link, right? And then for that reason is why it's important to be subscribed to my YouTube with my notifications turned on. So that way, as I start responding to questions, people are like, oh, I had that same question. Let me watch that video, or, this, that, or the other. So with this one, if we were solving for y, right, subtract the x cubed. Now, in the past, we had y squared. So to get rid of the inverse of y squared was square root. The inverse of y to the 7th is going to be the 7th root, right? It's the 7th root. And it's like square root, but the little script is going to be a 7 instead of being blank. And so when we take the 7th root, do we need the plus or minus? Yes, yay or nay. Do we need the plus or minus? If we take the 7th root, do we need the plus or minus, yay or nay? Because that's what it boils down to.
No, because it's odd. It's an odd root.
Because it's an odd root. That was awesome. Oh, I'm crying on the inside, like Mike Guy from Naruto. I'm like, they are learning. I got to finish that series. But yes, that's the reason, right? We take the 7th root on both sides. The index of the radical is odd, so we do not need the plus or minus. So that means that every x is going to correspond to exactly 1y. So then does this equation represent y as a function of x? We're going to say yes. All right, that was awesome. Right, and the reason I get excited because then it's like, okay, if at least like one or two, at least a few students in the class are getting it, then I do kind of expect them to like each one teach one, because I'm giving the best presentation that I can, but sometimes I know that it just gets to be old listening to your professor drone on, and it's like, hey, what you're saying isn't registering. But I personally, as a student and just watching, I've noticed that just sometimes when somebody that's closer in age says sometimes verbatim the same thing, it just clicks. It just clicks. So as long as somebody where you guys are like closer in age is getting it, then sometimes, it's easier to learn from your classmates than it is from the professor. Sometimes. But my job is to get as many people on board as possible. Let's see. So given this, let's try to turn up the speed a little bit. We got a solid a little over 5 minutes. So given this function, evaluate, right? So I'm going to use my shortcut. What I'm going to do is break out my trusty dusty rusty. If I can get it to work. Yes, that's what I wanted right there. And then I want this guy. Come on. Yes, looking good. Reload and refresh. So hopefully you have some kind of graphing calculator. Either you have one in person. I use this because, this is how we did it in the past. We had a graphing calculator. This is an emulator for a TI-83 Plus. There are a bunch of free online software. Some of them take a little bit of getting used to use them, but anything that you can use to kind of get through this stuff, right? I'm gonna go to my y equals, and I'm gonna type this in. Now that takes practice to type this in correctly. I'm gonna hit my x divided by, I'm gonna hit my square root, which is second x squared. And then I'm gonna type my 1 minus x squared, because you just gotta make sure your grouping symbols are proper, right? But this looks good. So then I'm gonna quit to go back to the home screen. And I wanna evaluate. Now it says type an exact answer. So if we get a crazy decimal, we're gonna have to go back and write it out, right? We got a solid 5 minutes. So let me see. On the right-hand side of the calculator is the button clear. To the left of that is the button that says VARS for variables. I'm gonna click on that. To the right is Y variables. Number 1 is function. Number 1 again is Y1. That calls on the function that we just typed in. So basically, the calculator is behaving like a function. So I typed in my function and I can evaluate it at specific values of X. So when X is 0, we get 0. So I'm just gonna go with that for right now. I'm gonna hit my 0, keep it moving. Okay. And the speed and the comfort comes from practice, right? You can't do something once and expect to be comfortable with it. You gotta, the constant repetition is where the confidence and the speed and the comfort comes from. When X is -1, so I'm gonna hit second enter to call on that function I just typed in, and I'm gonna replace 0 with -1 and just hit enter. Okay, now see it says divide by 0, right? So we can quit. And if you look at it, right? If you let X be -1, when you plug it in, when you plug in -1, -1 times -1 is going to be a positive 1. 1 minus 1 is 0, right? So the calculator was a warning, and then we confirmed it. So when we plug in -1, is divide by 0. So we say does not exist. Dividing by 0 is like do not exist, does not exist. Okay. So let's see, when we plug in 4, right? 4 squared is 16. 1 minus 16 is negative 15. This fails. We can't, for our context right now, we cannot take the square root of a negative. Square root of a negative is not a real number. There is a system. Now this is something. There is a system where we consider the square root of a negative to actually be a number. It's called a complex number. My question is there a system where you're allowed to divide by 0? And then what kind of things happen in that system? Because if you can create a system where you can take the square root of a negative, then what's stopping you from creating a system to where you can divide by 0? Then what happens in the system where you're allowed to divide by 0? That kind of questioning is where all this stuff comes from. People in the past, mathematicians in the past, would just be sitting around. And oftentimes in mathematics, whenever you need something and it doesn't exist, you just give it a name and you create a new system. And so that's why we're talking about all. That's how a lot of this stuff came about. They were just making stuff, pulling it out of their backside, right? But that's how the thinking goes, right? As a mathematician. So this one we said was not a real number. I know I'm kind of yammering a little bit. And then I think if we plug in 3/4, let's just do it really quickly. Let's recall our function and let's replace -1 with 3/4. So the calculator, even though it can spit out answers, you still have to interpret and ask yourself, well, what does that mean, right? Now it says we do get a real number, but it says type an exact answer using radicals. We got to follow the instructions, at least for this platform, right, to be successful. Well, that's one way. There's always another way to get stuff done, but the simple way is this, right? So we can't just put that answer in the way it is. So this one, I think we actually need to write out. We actually need to write it out. This is going to be it for us. We're going to try to get through this as quickly as possible, but still try to explain. Let's see. I think this is actually pretty good. Copy of it. So now, thank you. And I'm saying thank you to my device because it seems like you have to be gentle with it and keep your energy clear. Because if you start cussing it, it's going to respond and it's going to just throw more of a tantrum and be less responsive until you calm down. And I'm going to take this and put it, there you go. Thank you. All right. And then I guess it's going to be enough space. And come on. There you go. All right. So for x, okay, so we're evaluating when x is 3/4, right? So let's plug in. We're going to say 1 minus 3/4 squared. We're taking the square root of all of that, and that's divided by 3/4, right? So we're just evaluating this. And this is, let's do this real quick. This is g of 3/4. So starting with this guy, 3/4 times 3/4 is 9/4. So that's going to be 4/4 minus 9/4. We're taking the square root of that result, and that's under 3/4, right? I'm going to continue over here. 4 minus 9. Sorry, that's not right. That's not right. 3 squared is 9. 4 squared is 16. All right, 16. So then instead of that being 4/4, that needs to be, thank you. I know we're about done. There needs to be 16/16. Because what I had before, we were about to get a non-real answer, and I know that wasn't right. I was like, wait a minute, I did something wrong, right? So now, in this form, they got a common denominator. 16 minus 9 is what, 7? So then I'm going to do some simplification. So that's going to be the square root of 7 divided by the square root of 16, right? And then again, that's still under our 3/4. So now we have one fraction divided by another. We do keep, change, flip. Let me abbreviate that here. We're going to say keep, change, flip.
Professor Phifer,
Yes.
Really quick, how did you get 16 over 16?
So we had this 1 minus 9 over 16.
Oh, right. Okay.
Okay, that's a good question.
Thank you.
So, if we keep going, let me just line up my equal signs a little bit better. So then if we keep going, we got 3 over 4 times, now if we flip it, it's going to become what, 4 over the square root of 7. So then now we're ready to cancel because it's all multiplication and division. So these two, a number divided by itself is 1. And then ultimately we finish, and we can stop here for right now, is the square root of 3 over square root of 7. In some instances, we rationalize, and we probably should rationalize here. Let me just try to submit this because we're out of time, so just hold off if there are questions. Let's hop back over. Hop back. We got 3 divided by the square root of 7. So then right here, part A, we got 3 divided by square root of 7. Okay. Oh, and one other thing before we submit that, we can check it here. All right. So if we say 3 divided by the square root of 7, we should get the same answer. Right. See, those decimals are exactly the same. So then that was a confirmation. So if this were an exam, we can be confident in our result. All right. And we're going to put a pin in it right here. Okay. All right. Again, major announcements. 1, be sure that you're doing your lab with Dr. Lamar. If you have any questions on the lab, you have to contact her because she has all those details. For us, you definitely want to make sure that you have your full by now, most people, if not all, should have full access to Pearson. Again, exam 1 is going to become available this upcoming Sunday. I would hopefully, and again, you can anticipate prerequisites for the exam in the form of passing quizzes for weeks 1, 2, and 3. Unlimited attempts at the exam is going to take your highest score. My recommendation is, as soon as it becomes available, go ahead and attempt it, right? You want to try to be working on it as soon as possible. When we come into class next week on Monday and Wednesday, it's really just going to be, I treat those like exam weeks. So I'm really just on the Zoom call. I'm just sitting waiting for questions, right? So if you've attempted the exam in advance, you can actually ask any questions during class on next Monday and Wednesday, and we can work on it together and you can use the result. Everybody has their own exam. Another piece of information is that each time you take the exam, it's going to change, like a completely different set of questions, right? So I just wanted you to kind of be aware of that. Are there any burning questions before we go our separate ways for the weekend?
Yeah, I have one more question about the problem we just did,
Okay.
if you don't mind.
Mhm.
Okay, so when you were multiplying 3 over 4 times actually, how'd you get 16 over the square root of 7?
All right, okay. So is this part okay that I have circled in red?
Yes.
So then whenever we have one fraction divided by another fraction, then we do keep, change, flip. Is that okay?
Yeah.
Okay. So then for keep, change, flip, we keep this one as is. You see it right here. We change division to multiplication. You see it here. And then we flip this guy. So instead of being the square root of 7 over the square root of 16, it became the square root of 16 over the square root of 7.
Okay. I forgot the square root of 16.
Is that okay?
Yeah.
These are good questions.
Okay. Thank
All
you.
right, my philosophy is the only dumb question is the one not asked, right? If we knew it all, we would not be in this class. So we're here because we're all here to learn, grow, and progress together. Last call for alcohol. I need to replace the alcohol with something else, but for this context. Any other burning questions before we go our separate ways? Going once, going twice. Forever hold your peas and rice. Okay. Work hard, play hard, get your work done, enjoy the city. This stage in your life is, you don't get this back, right? In college is the easiest time to travel and to do stuff, because once you leave Morehouse, You're going to be hit with like responsibilities. That means like earning money, you know, taking care of yourself, eating, feeding. Don't get children. I mean, get children, you know, you got to prosper, but you know, that's responsibility. So just try to enjoy yourself while you're a student, while you can. That I know I traveled. I went out of the country as much as I could. I know times were different. We didn't have pandemics, monkeypox, all this other stuff. We had racism, but you know, but try to enjoy your time. Okay. So on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Have a great weekend.
Thank
Peace.
you.
Thank you.
Thank
Have a
you.
nice day as well.
Yep. Let me check the chat. The chat looks good. Let me check here. Mr. McKitty, did you get your question answered, Mr. McKitty?
Well, no, I just had a question about the online lab. I'm
How
like,
did you say your first name?
Suna?
Susana?
Suna.
Suna, okay. I was like, that looks like Naruto, Susanoo. I was like, if he said Susanoo, I'm gonna flip. You said a question about
Lab, because when I go there, well, so basically what happened was I took
say it again.
well, so like I had a question about the Alex lab. Because so like when I took the placement exam, I took it in the summer. I didn't do that well, and then I retook it past the deadline. And I go back into it, and then it says that I'm in prep for calculus, and so I don't know what I'm supposed to do then.
So talk to Dr. Lamar. She has those details. Just you need to contact the professor, and she'll give you the details on what you need to do. Don't take my word for it, but my experience in the past is usually, like if you start at prep for calculus, usually it's like you want to finish at the prep for the next one. But just talk to Dr. Lamar. She has the details on what she expects you to do. You know, that's the proper thing to do. Just contact her.
Okay, thank you.
Mm-hmm. Yep. Any other questions? All right. And on that note, we're going to end the session here. And again, from one beautiful mind to another, enjoy the rest of your day. Peace.